Factor now. Factor now. Number that multiplies evenly in original term by the GCF. Factor. The resulting terms go into the parentheses. Now it's just another kind of factor. Difference of squares. A squared minus b squared is a plus b times a minus b. Yeah. Difference of squares. A squared minus b squared is a plus b times a minus b. Yeah. And if you have factors with polynomials, don't cancel till there's factors out of the way. Out of the way.
All right, well, welcome back, Algebra 1 students. As we're looking at factoring special products, one of those special products is the difference of squares that Song was just talking about. So 7.7 in Big Ideas, Algebra 1. So right there it says we're factoring out difference of two squares, and we're also factoring perfect square trinomials. Those are the two special products that we learn in this lesson. So let's go ahead and check out our cartoon for the day. It's a Far Side cartoon. It's the Boneless Chicken Ranch. Boneless Chicken Ranch. So this is where we get our, I guess, where we get our boneless chicken from. All the chickens have no bones, so they're just like lying around. They can't go and do anything. Completely boneless. All right. So difference of squares, difference of two squares pattern is where you have a binomial, and we're going to factor a binomial. So it's a special binomial that we factor. So here's an example of one, x squared minus 9. So simply put, we're going to basically, each of these have to be perfect squares. There has to be a minus between them. That is the difference of squares. If there was a plus, that's not a difference of squares, and that cannot be factored. You can only factor it when it's a difference of two squares. So if this was x squared plus 9, then there's nothing we can do with it. It's already as factored as it could be. So, but if it is this, where it's like x squared minus 9 or a squared minus b squared, where we have perfect square terms on both terms here, and there's a minus in between, then we can basically break apart the a to a times a, the same thing times itself, and b times b, the same thing times itself. So you can see over here, x squared breaks apart to x and x, kind of like our simple method. And then the 9 breaks apart to 3 and 3, the same number times itself, 3 times 3. So 3 squared is that 9. And then 1, the signs for those, 1's plus, 1's minus, because we got to get a negative one here. If we were to FOIL this, we would end up canceling out the outside and the inside terms. We have negative 3x on the outside, positive 3x on the inside. That would cancel out that middle one, leaving us just with those two terms of x squared minus 9. All right, let's go ahead and try some here. Here's an example. You don't need to write these down, but we can just see this. Here's an x squared minus 25. We just saw one similar to that. So it's going to be where you have 5 squared, and so it's going to be an x plus 5 and an x minus 5. So two binomial parentheses is what these factor to. Now this one, 4z squared. 4 is a perfect square, making this a perfect square term. So it's just going to see what do you need to multiply 4z squared by times itself. So in this case, it's going to be 2z times 2z. So that's going to be up in front. So 2z times itself will give you the 4z squared, and then the 1 times 1, and 1 plus and 1 minus. So it's always 1 plus and 1 minus. They have different signs because it is a difference of two squares. All right, so now into our page 237. Here's our extra practice. I'm going to do 2 of these out of these 6. So let's start with just number 1. And I'll show you number 1 and the way we would do this. So it's a difference of squares right here. We can tell that it's a perfect square with s squared. It's a perfect square with 49, because that is 7 squared. We want to think of this really as a 7 squared. So two perfect square terms, and it's got this minus in between here, making a difference of two squares. So we can factor this to two binomials. Put the empty two binomials down. Start with s times s, and 49 is 7 times 7. And then just 1 plus and 1 minus. It doesn't matter whether you put the plus first, then the minus, or the minus, then the plus. So that's our answer here on this one, and it's that simple. All right, so go ahead and pause the video. Try the same thing for 2 and 3. Try doing the same thing for number 2 and number 3, and then I'll show you those two answers. Okay, so hopefully you have an answer for 2 and 3. So 2 has got t squared minus 81. 81 is 9 squared, so it's going to be 9 and 9. So t and t up front. The two 9s, 9 times 9 is 81, 1 plus, 1 minus. 16 is 4 squared, so it's going to be 4 and 4 in front, and the x is behind on this one. So it's going to be 4 times 4 up front for the 16, x times x for the x squared in the back, 1's plus, 1's minus. So again, it's same thing, it was just kind of reversed with the variable being second and the number being first. Now let's take a look at number 4 down here. So number 4, we have a 4g squared minus 25. So 4g squared, we're going to think of two things that would multiply themselves times each other. So obviously 5 times 5 is 25, 4 is 2 times 2. So this is going to be a 2g and a 2g up front. 2g times 2g gives us this first term. Remember, if I just use FOIL, first terms, multiply to give us this one. And then 5 squared, so 5 times 5 is 25 for the back. They have to be different signs, 1's plus and 1's minus. I typically put the plus first, but you can put the minus first if you want to. And that's it. That's all we have to do is just to factor these. These can be factored very quickly and easily. First, we do need to recognize that it's a difference of two squares, so we know we can factor it. Because again, I said, these two have to be perfect square terms, has to be a minus sign in between them. It can't be a plus. If that was a plus, then it's not factorable. All right, so go ahead and try 5 and 6. Yeah, so pause the video and do 5 and 6 and then play to check those two answers. So here for number 5, you should be checking your answer then. 36 would be 6 times itself, or 6 squared. So 6h will be up in front of each one. 121 is 11 squared, so 11 should be behind. So it's be 6h, 6h, then the 11 and the 11, 1 plus, 1 minus for the two binomials. And then for number 6 here, 81 again is 9s, just like we saw in number 2. 49 is 7s, like we saw in number 1. But again, the k is in the back here, so it's going to be 7 k's are in the back. So it's going to be 9's up front, 9 times 9, and then the 7k and 7k in the back, 1 plus and a 1 minus. Again, you can always check to see if you're correct by just using FOIL. Multiply these two back and see that you get these two. What would end up happening is, as you multiply, your first terms would give you the 81, the last terms would give you the negative 49k squared. The outside and the inside will cancel each other out though. This would be a negative 63k and this would be a positive 63k. That would cancel them out. Alright, so let's go on to our next part. Now the next part says use special products pattern to evaluate the expression. I'm just going to show you number 7 and then try to see it and just give you a chance to try some of these other ones here. So how would we do this with using this difference of two squares? So simply put, we could see that it's going to be 57 squared and 53 squared. So if I did the same thing as we just did by putting these into two binomials right here. So I'm going to do this one in green. Let's do it green here. So if I took two binomials down and I put the 57 times itself, 57 and 57 go up front. And then 53s are in the back. 53, 53. And 1's plus, 1's minus. So when I add these two, like 50 and 50 would make 100, 7 and 3 would make 10. So this is 110 right here, times 57 minus 53, well, that's basically 7 minus 3 then, is just a 4. So it's 110 times 4. We can do this mostly in our head, I hope. This is going to be like 44 with a 0. So 440 is what that multiplies out to be. So it's just a way you can think about multiplying numbers, putting these two together with a difference of squares pattern. So go ahead and just pause the video and try to do the same thing on these other ones, and then I'll just play it and check to see if you can do the same thing. Just put them in the pattern here and then add the ones, subtract the ones, and then multiply. See if you can do that without a calculator. Alright, so hopefully you have an answer now from 8 to 12. You tried these. They're kind of a fun thing to do, I think, just to try and see if you can get the answer right. Using this pattern instead of like using a calculator or something. So in the first one you got 38 plus a 32, 38 minus a 32. So those two add to give you 70. These two subtract to give you a 6. And we know 7 times 6 is 42, so 42 with a 0, 420. Number 9, we got 68 plus 64 and 68 minus 64. So these two add and give us 132. and this one is a 4. Now this one you might not be able to do in your head so much, but you can probably do it on the side, putting 132 over 4, and do a quick little multiplication. You should have got 528 for that one. For this one, you got 45 plus 40, 45 minus 40. So 45 plus 40 is 85, 45 minus 40 is 5, and 85 times 5 is 425. Number 11. So it's going to be 79 plus 71, 79 minus 71. So adding these two, you get 150. When you subtract them, it's like 9 minus 1 is 8. 150 times an 8, again you can put that on the side if you need to do kind of a column form, is 1,200. You can think of it, 8 times 0 would be 0, 8 times 5 is 40, there's the other 0, and if you then carry a 1, or carry the 4, and 8 times 1 is 8 plus 4 more is 12. So you can kind of do this in your head. And then our last one here, 86 plus 84, and then 86 minus 84. So when you add them together, you get 170. Subtracting, it's just a 2. And then just 170 times 2, 340. So that's all you need to do on those ones. So the main thing of this lesson, though, is what we did on 1 through 6 and what we're going to do on our next part with trinomial squares. All right, but before we go there, let's go ahead and look at our joke of the day. Why aren't koalas actual bears? Why aren't koalas actual bears? Well, because they don't meet the qualifications. Actually, that's a typo. They don't meet the qualifications. I should fix that part. So they don't meet the qualifications to be a bear, apparently. There you go. All right, moving on to our core concept for the perfect square trinomial pattern. So the perfect square trinomial pattern is, it's in a trinomial. You have your three terms, like this right here, x squared plus 6x minus 9, or x squared minus 6x plus 9. What you could do on this, you could always just use either the simple method or the star method, in case star would be if you had a number in front here, which is possible sometimes. So you can always still use those methods. But what ends up happening with this, if it is a perfect square trinomial pattern like these, what you'll end up seeing is that you're going to get two binomials exactly the same, x plus 3 and an x plus 3, or an x minus 3 and an x minus 3. So what we can do then is just simplify it down to just one binomial squared, x plus 3 squared, or x minus 3 squared. That's what we see here. So we see on this one, it's going to be perfect squares for the first and last terms. So it's kind of like the difference of squares, those that had the a squared and the b squared, for your first one and your last one. But there's a middle term where you have 2 times ab, so it's this number times this number, that's what the squared number is, what you're squaring, and times 2. And notice that your b number has to always be positive. So that's true there. So like right here, the 9 is positive on both of these. This one would be, 9 squared is 3, and this would be like a 1 right here, or just an x squared. So basically a 3 and an x. So 3 times x times 2 would give us that middle term of 6x. That's how we know it's there. We know it's a perfect square trinomial then in that case. So basically two numbers that basically multiply to give you 3, or multiply to give you 9, the same number. 3 times 3 is 9, 3 plus 3 is 6. That's another way you can think about it as well, especially on these simpler ones with the simple method. All right, let's move on to looking at these here. So here's 16 would be 4 times 4, 8 is 4 plus 4, that makes a perfect square trinomial pattern, trinomial square pattern. So we can think of it as right here the same binomial where it's going to be the n and the 4, and it's a plus in the middle. This sign right here, the middle term, will always be what's in your binomial, n plus 4 squared. There's two binomials exactly the same. So on this one, you have a 4 and a 9. So if you multiply 4 times 9, that's 36. 36 is 6 times 6, and 12 is 6 plus 6. So there's another way you can think of it as the trinomial square, and it's got a minus sign in the middle, so there's going to be a minus sign in our binomial. So this is going to be 2x, and this is going to be 3. So we're going to see a 2x minus a 3 squared, and that's it. All right, you didn't need to write those down. Let's go ahead and look at our extra practice again. Now we're on 238. And I'm going to do number 15 and number 17 off this one, and then you'll do the other four. So number 15, so let's take a look at 15 here first. So we have r squared minus 26r plus 169. So 169, we're thinking of a number that would multiply itself to 169. So you could take the square root of this as well to see, is it a perfect square? It's another way you can always check to see if it's a perfect square. You can even use your calculator to do that, to check that, to see if it's a perfect square. 169 square root is 13, so we do know that's a perfect square right there for that number. So 13 times 13 is 169. 13 plus 13 is 26. So in this case, we know that they're going to be turning into a binomial squared. So a binomial square, we're going to start with the r up front. R times r is r squared, and then 13 is in the back. The sign here in the middle is negative, so it's a negative there. And that's it, just r minus 13 squared. If I was to use my simple method factoring, and I just didn't realize it was a trinomial squared, I'd be putting r's up front. Two numbers that multiply to give me 169, that add to give me the 26 would have to be 13 times 13. I'd have to come to that conclusion that that's 13 times 13 for this, 13 plus 13 for this. They're the same sign, they're both negative, and so you can see there's two exactly the same. So that's why we can just simplify it to r minus 13 squared. So go ahead and pause the video now, try 13 and 14, and then actually you can do 13, 14, and 16. Maybe do those three. 13, 14, 16, and then we'll come back and do these two in a minute. So try 13, 14, and 16 this time. Alright, so hopefully you have answers now for 13, 14, and 16. So for 13, you have 8 times 8 is 64, 8 plus 8. So 8's your special number there, so it's going to be an x plus 8 in the binomial. It's got to be the middle sign here. That's got to be plus. So that's our answer for this one. This one, 196, that's going to be 14 times 14. Again, we could have done this. Is 196 a perfect square? 196 square root of that is 14. So that's where you could have gone. So 14 times 14, 14 plus 14 is 28. So it's a p and a plus with this one, 14. P plus 14. And don't forget the square, because there's actually two of them, just like we saw when we did the simple method here. For 16, 81 is 9 times 9. 9 plus 9 is 18, so 9 is that special number with a minus. A minus 9 in the binomial, and don't forget the square. All right, for 17, let's do 17 together, and then you can try 18 on your own. So for 17, we can think of, if we multiplied these two numbers, that's kind of big, but what we can recognize is this is 6 squared. Well, we already see the c squared, but 6 squared, this is 7 squared. This is a plus right there. And then if I multiply 6 times 7, 6 times 7, that's 42, and then also times it by 2, I get 84. 42 times 2 is 84. So that definitely means this is a perfect square trinomial square pattern. So we're going to use the 6 and the c squared. A 6, actually not a 6c squared. The squared's on the outside already. Just a 6 and the c. So 6 and c for the first one, 7 for the second one, and then again, plus goes in between. So 6c plus 7 squared. There's two binomials there. If I did the star method on this one, and I multiplied this through with star method, I would get this, 6c plus 7, and I get two of them. So that is our answer there for 17. All right, so go ahead and pause the video and try 18. See if you can do 18 correctly. All right, so you should have done 18 now, and so 100 is 10 squared, so a 10x would be up front. 1's going to be in the back because 1 squared is 1, and with the minus sign in the middle. So we can definitely see it's a trinomial square, because if I did multiply a 100 times 1, like the star method would do, that's 100, so 10 times 10 is 100, and 10 plus 10 is 20. And so it's going to be a 10x minus 1 in the binomial with the square there on that one. All right, let's move on to our next part here. And oops, I forgot to put these out. So let's go ahead and look at this then. I was supposed to do this, but it's all right. So we'll actually look at doing these, and then we'll just do these together. That would be fine. So I've already done 19, 22, 23. So let's just start going through them. So with 19, again, it says solve the equation. We're solving the equation on these ones. So you want to make sure it is equal to 0. Always make sure it's equal to 0. And so this leaves us with a difference of squares right here to factor. So we're going to factor the x squared minus 144 with difference of squares. Gives you those two factors, x plus 12, x minus 12. 12 times 12 is 144. One's plus, one's minus. Zero product property would be next. So set each factor equal to 0. We're going to subtract 12 on this one, giving us a negative 12 answer. In this one, we're going to add 12 to both sides, giving us a positive 12 answer. For number 20, let's go ahead and start this one, and then I'll have you try it on your own. Actually, let's go ahead and let's talk through. Let's go just do the ones I have open here. 22. Let's take a look at 22 next. So I have this one with d squared minus 4d plus 4. It's equal to 0, so it's in standard form. If we were to not recognize that it's a trinomial square, we might see that we could do this. So if I just did the simple method, d and d go up front, what two numbers multiply to give me 4? That would add to give me 4. That's 2 and 2. They're the same sign. They're both minus. So again, I could have seen that that was a trinomial square and had written it out as like this, d minus 2 squared. So I could have done it that way. And then just use one of these, d minus 2. There's only going to be one answer because it's going to give us the same answer here. Just add 2. There's only one answer for this one, as d is equal to 2. For number 23, this one's got some fractions in it. And so I might show you how to do these without fractions. We can do it as well a different way here in a second. But you can see n squared, you have 2/3 n and a 1/9. I have to get this equal to 0. I'm going to add 1/9 to both sides. So now it's equal to 0 here. So the first thing is write in standard form. Adding 1/9 here. That's all I'm doing. Cancels it here. So now I have 0. Adds it to this side on the left. And so this is a perfect square. 1/3 times 1/3 is a 1/9. And then 1/3 plus 1/3 is a 2/3. So you're going to say n plus 1/3 squared. And so since we just have that one binomial, we're just going to subtract the 1/3 from both sides. And so we get a negative 1/3 answer for n. So n is equal to just negative 1/3, only one answer. All right, for number 20, first thing we need to do is set this equal to 0. Subtract 49 from both sides. So you have 9y squared is equal, or not equal yet, I just did the equal sign, minus 49 minus 49 equals 0. So now that's a difference of two squares. So I'm going to have you pause the video and try doing 20 and 21 on your own. Try to do these two now. Now that I got this equal to 0, factor this, and then use the zero product property. This one, 21, go ahead and factor this. It's a trinomial square, and then use the zero product property. Okay, so you should have done 20. So with 20, we get two binomials on 20. And it's going to be 3y up front, 7 and 7. One's plus and one's a minus. And so our answer is basically when we set this equal to 0, 3y plus 7 equals 0, and 3y minus 7 equals 0. So we're going to subtract 7, so it's going to be 3y is equal to negative 7. This one you add 7, 3y equals positive 7. So now when we divide by 3, y is going to equal a negative 7/3, and y is going to equal a positive 7/3. So there's my two answers right here for y. Number 21, we're going to get one binomial squared because it's going to put c up front. 7 times 7 is 49, 7 plus 7. So it's a 7, and it's got to use this positive sign there. And it's equal to 0, so it's just C plus 7 is equal to 0 for 0 property. Subtract 7, so our answer is just going to be C is equal to negative 7. All right, let's take a look at number 24. I do need to set this equal to 0. So we'll start by doing that. I'm going to add, since the k squared is negative, I want to make it positive, so I'm going to add k squared to both sides. It's going to go up in front of this one. So it's going to start off with now k squared minus so I'm subtracting the 6/5 k plus 9/25, and it's equal to 0. Okay, so at this point we could see that my 9/25, so 9 is 3 times 3, that's 5 times 5, so 3/5 and 3/5. 3/5 plus 3/5 gives us a 6/5, so we could just use that. So we could just put it into the binomial squared equal to 0. K is now up front. Minus sign, and it's a 3/5. 3/5 times 3/5 is 9/25, and 3/5 plus 3/5 is 6/5. So when we just do k minus the 3/5 equal to 0, we're going to add 3/5, so k is going to equal a positive 3/5. We're adding 3/5 to both sides to solve for k. So that's our final answer there. Now, just in case this was maybe a little bit challenging for you on 23 and 24 with the fractions, there's another way you can do this problem, and I wanted to show you that. And it's going to kind of go off of number 23 right here. I'm going to show you an example here, just like 23. So this is basically what 23 is right here. When we got it equal to 0, we added that 1/9. What we could have done, instead of seeing that this is a 1/3 times a 1/3, I could have got rid of my fractions. I could have multiplied the whole entire thing by 9, which is the common denominator between 3 and 9, because 3 goes into 9. So if I was to multiply everything here by 9, it says multiply each side by 9, I'm going to get 9 times x squared is 9x squared, 9 times this 2/3 is a 6x, and 9 times the 1/9 would just be the 1. It would cancel the 9 out. This one's going to cancel 3 out, but then it's going to be 2 times 3 on top. And now I can factor this. It's a trinomial square as well. That's going to be 3x, and this is going to be a 1. So we could see it's going to be 3x plus 1 squared. So I can do this, and then set it equal to 0. Just set one of them equal to 0, and then solve. Subtract the 1 and divide by 3. So I get a negative 1/3. So there's another way that you could have done it with the fractions. If you ever see fractions in an equation, you can always get rid of them by multiplying by the common denominator of your fractions that you have. All right, we have one last one to go through. So number 25, it says the dimensions of a rectangular prism are x plus 1 feet by x plus 2 feet by 4 feet. The volume of the prism is a 24x minus 1 cubic feet. So what's the value of x? So when it says volume, we need to know what is the formula for the volume of a prism. So volume is simply just length times width times height. It's a rectangular prism. So remember, if we think about area of a rectangle, that's length times width. But now, since it's a prism, that's going to actually have a height to it now. And so it's a rectangular base, and it's like a tall building. You might want to think of it as. Like it could be a prism. Or even a box, for instance. A box is also like a prism, a rectangular prism. So it's the length and the width, which would be like the side of the box, and then the height, which would then include all of the space that's inside of that box. All right, so we're just going to plug everything in. We know the volume right here is 24x minus 1. These are the dimensions, like length, width, height, the 3 dimensions here. It doesn't matter which way you put them, so I'm just going to plug them all in. So my volume, my length, width, and height are these 3 dimensions. And we're just trying to find the value of x, so we need to solve this for x. So first thing I got to do is simplify this side by multiplying. So I'm going to multiply, keeping this side the same. I'm going to multiply the 2 binomials. So that's going to be just kind of using FOIL. The first one's giving me x squared, outside's 2x, inside's 1x, that's a 3x in the middle, and then 1 times 2 is 2. And then we multiply this by 4, so we need to distribute the 4 into all of this. And so now that's giving me still my 24x minus 1. But now when I multiply by 4, I got 4x squared. Multiply by 4, it's 12x from the middle. Multiply by 4, it's 8 there at the end. Okay, so now I need to get it equal to 0 to solve for x. So I'm going to move these two terms now over to this side. I'm going to subtract 24x. I'm going to add 1. That's what I'm doing here. It cancels those out. It'll cancel those out. Do the same thing on this side. Subtract the 24x from the x term here and add the 1 to the 8. And so now that's going to give me 0 on this left side. Now I get my 4x squared. These two make a negative 12x. That makes a 9. This is now a trinomial square right here that we have. Perfect square here with 2x times 2x. This is 3 times 3. Or you can think of, 4 times 9 is 36. 6 times 6 is 36. And 6 plus 6 is 12. So we can use that. A 2x and a 3 with a minus sign in the middle. And then we just set one of those equal to 0. So a 2x minus 3 equals 0. Add the 3. And so that gives us 2x equal to 3. Divide by 2. So our answer is just 3 over 2 for x. So 3 over 2 is our answer for x. It could be a 1.5 decimal if we wanted to change it to a decimal. All right, so that concludes our lesson here on the special products of factoring the special products of a difference of two squares and trinomial squares. You need to be able to recognize those when you see them. All right, have a great day, and I'll see you on the next lesson.